So now in the next part, I'm going to, prove this theorem conversely. So conversely, what we have to do is first, I can say let integral over the curve C A dot dr is basically the independent, I can say independent of the path C joining any 2 points. A dot dr, that is independent. Now further is we choose these points as the fixed point. I can say because I can say that integral is independent of the path, that means it only depend upon the 2 points. So I'm here choosing these 2 points as the fixed point. So P1 is basically, I can say P1 x1 y1 z1 is, you can say, fixed point, and P2 x2 xyz is variable. So the result is a function only of the coordinates, I can say x, y and z of the variable endpoint. Then I can say that putting the values in the function, that phi of, I can say, xyz, that is equals to integral from point x1 y1 z1 to point xyz a dot dr. Further that I can write integral from x1 y1 z1 to xyz a dot dr over ds into ds. I can write it as, so by differentiation on both sides, I can say that d phi over ds, that is equals to a dot dr over ds. Now further step is, as we know that a, that is equals to del phi, so putting that value of a, that is equals to del phi here, so that means del phi dot dr over ds, here the value of this one. Now further is, what we have to do is, I'm comparing these two equations here, equation 1 and I can say equation 2. So that means a dot dr over ds, that is equals to del phi dot dr over ds. So that means del phi dr over ds minus a dot dr over ds. So taking common dr over ds, that means del phi minus a into dr over ds. So here I can say that since dr over ds is the unit tangent vector and that is not equals to 0, therefore I can say that the above equation becomes del, you can say, phi minus a, that is equals to 0. So that means a, that is equals to del phi. So this is the proof. What we have to what we done here, we first, in the first part, we take this condition that a, that is equals to del phi, and I prove that, you can say, the line integral depends only on the points p1 and p2 but not on the path. But here conversely, I take the line integral that is independent of the path and I prove this condition that a, that is equals to del phi. So this is the proof of this whole theorem.